I'm going to talk today about horizontal sharding with Vitess. My name is Rohit. I'm presenting it along with Andres. I'll be presenting the second half of the talk. So we take a quick look at why we shard, and then at Vitess architecture, and then deep dive into how horizontal sharding is done in Vitess. So you would typically choose to horizontally shard once you have maxed out your instance sizes, you have tuned your database, you've done everything, and you're requiring maybe to use really high-end hardware. And since you need redundancy across your fleet, you end up needing a very high budget. So with horizontal sharding, you also get massive scalability, and you can go up and down on-demand scaling. Let's say you have Black Friday, you want to scale up your database, and then after the holidays, bring it down. It's more resilient to hotspots. Hotspots in certain applications won't bring down your entire database. These are commodity hardware, which I talked about earlier. So overall, with a sharded system, you end up saving costs as well. Functionally, you have isolation of tenants, where for sensitive data like financial companies, you can put them in a multi-tenant system, put them on different shards. Similarly, if somebody is paying more, you can have larger hardware for specific shards. So in horizontal sharding, you have a common schema on all the shards. So that means the tables are actually spread across the database. So each database will only have a subset of the rows. You typically want to put the related rows on the same shard to minimize join costs. There are challenges that come with it, depending on your data access patterns. So you might end up with a lot of cross-shard queries if you have not designed it properly, which are expensive. And features in the database like foreign keys, unique keys, auto increments don't really work because you're not using a single database anymore, and you will have to redesign that. So let's quickly look at the Vitess architecture. So Vitess is a CNCF graduated project. So the scalable in this definition is from horizontal sharding. Some key points about Vitess. It's cloud native in the sense that it uses a lot of services. It's built with services which can be containerized. So it works very well in the K8s environment. Highly available. We have an orchestrator which can fail over primaries automatically. And underneath it uses MySQL. So Vitess provides the illusion of a single database. So it does the query routing among all the physical databases that it has. We'll look at it in the next slide on the architecture diagram. And the user essentially is just targeting it as if it's a single database. So, and it talks the MySQL protocol, of course. So that allows it to work with a lot of legacy code. Third-party applications like WordPress, large installations have been ported to Vitess. And lots of database frameworks, ORMs, Rails, Laravel, SQLize, Hibernate, Spring have been ported over it. These are some of the companies with larger clusters which use Vitess. PlanetScale arguably today runs the largest set of clusters in the world with hundreds of thousands of MySQL databases. So the application talks to Vitess via VTGate, which is a proxy. So VTGate will talks MySQL. It takes the query, decides where it needs to route it to. If required, does some aggregation, collects the results, and sends it back to the client. It discovers the topology using a topo server like etcd or Zookeeper. The databases are organized in key spaces. So the simplest cluster would be a single key space with an unsharded key space, where you have at least two servers. You have the primary and replica. They replicate using MySQL replication. VTGates talk to a sidecar process called VT-tablet, which controls the MySQL D using sockets or TCP. Additionally, we have some other components like VTCTLD is the control plane. So you can monitor and manage the cluster using a couple of CLI and the web UI called VTadmin. VTorg is the orchestrator. So I'm not going too deep into all this because we want to focus on horizontal sharding essentially. So there are three aspects to look at. One is how do you shard, right? How do you address a shard? Then how do you actually move the data between the shards and the query planning? Andres will talk about the query planning. Just as an aside, we also want to say that people also talk of vertical sharding as sharding, where you split tables across databases. That's also supported out of the box in Vitess using something called move tables. So in horizontal sharding, the key space we mentioned will be a sharded key space, will be two or more shards. It is defined by something we call a V schema. The V schema has all the tables, a list of all the tables, and the sharding key per table. Essentially, it decides which row you want to map to which shard. So the sharding key can be one or more columns. In the simplest, it would be your auto increment primary key. Then there's also something called a Windex, which is a mapping function, which takes the values in these columns and maps it to which particular shard it is. You could also have secondary Windexes. Let's say you have a lot of different common where clauses. You could create Windexes which point to specific shards for the values in those columns. That's all done automatically behind the scenes. There's a concept called reshard replication workflows. We will look at that a couple of slides later. Since auto increments are not don't make sense in this multi-database environment, we have a concept called sequences. Sequences are the table which manages the sequences lies on an unsharded key space. However, VT gates will automatically cache and request this unsharded key space whenever there's an insert to get the auto increment value. Similarly, for data locality, if you have joins to look up tables, you don't really want to go cross shard. So the way you manage it is you manage it in an unsharded key space, but there's a concept called reference tables and a materialization built into Vitess. These will automatically replicate the data onto the shards, and VTGate knows how to plan it, how to look for those that data. So this is how you refer to shards. So the dash is essentially unsharded. So what it means here is at the end, the Windex maps a row, the values in particular columns that you have selected as the sharding key, into a 64-bit value, which we call the key space ID. And this range is split into contiguous ranges depending on the number of shards you want. So as an example, we can look at dash 80 dash. Let's say you are mapping your ID directly as 1:1 to the key space ID. If the MSB is 0, you would put it in dash 80. Otherwise, you put it in 8 dash. There are lots of more sophisticated functions to make sure that data is distributed correctly. And choosing a Windex is something that you do as part of sharding. The Windex types, binary is what I just mentioned, 1:1 map. You could also hash the value. If you have varchar primary keys columns, you would use the Unicode hash. There are multi-column hash Windexes as well. For example, if you want to do geolocation, right? You want to have some data for some tenants in a specific AZ or a geographical zone, let's say for GDPR reasons. You would use multi-column indexes with the country ID as one of the columns. And finally, you can go to a custom JSON map where you can say, this is my column, based on this ID, you map to this shard. But overall, the app does not need to know about the underlying sharding. So you can reshard without the app actually having to change. Of course, you need to be aware that you're now doing distributed queries. But other than that, you're not hard coding the shard number anywhere. The sharding key, while you expect it to be chosen carefully, you can also change it later if you find that it's not really working out. However, you need to do something else. I'm not going to go into details, but slightly more expensive operation, but it can be done. Yeah, so now we are looking at how we are actually going to do the sharding. You've defined your V schemas. You have decided which indexes you want for the tables. And it's as simple as this. There's a command. So you specify which shards. Let's say you're going from unsharded to sharded. And the first one is for the 2 shards. You create the workflow. The second one is in case you find that there's a hotspot on one of the shards and you want to split it further. So shards are not uniform. I mean, they can, be split in any distribution across that 64-bit space. I think the largest customers we know today have, 256. Hoping, yeah.
256.
And they're planning to go to 512, I think, in a couple of years. So that's the largest one that we know. So this command is run in the CLI using the VTCTLD client interface. So when you create the workflow, it starts actually replicating data from the source to the target. We'll look at the next slide of how that is done. So once you have the replica lag low, that is the target is tracking the source closely, you call switch traffic. You can switch replica reads first and then writes. When you switch writes, we stop writes on the source, then let the target catch up to the source, and then we turn on writes on the target. So all this is done automatically. The reads and writes are stopped using topology keys by VTGate understands that. So if it sees that a source has a particular key, it will either return errors, or we also have buffering for like up to 30 seconds or so. Configurable limit, you can buffer the queries while we are doing the resharding. When you switch writes, by default, a reverse replication is also done to the source from the target. So it is always possible until you have marked the workflow as complete, in which case where you say you're happy with the workflow, you can always switch back to the source. And you may do it for 2 reasons. One is when you're moving from unsharded to sharded, there are several data access patterns that might emerge which you have not taken care of. Like there might end up being a lot of cross-shard queries which you're not expecting, which will bring down performance a lot. You might be depending on unique keys, and they are no longer unique because now they're on multiple databases. Several such things can emerge. Other thing is that if, let's say, you're down sharding, after the holidays you say, I think I only need 2 shards, I go from 4 to 2, and you find that your traffic is really suddenly high and performance is bad. You can simply just reverse, and again within the... So what I didn't mention earlier is the typical downtime that is there when you switch writes, we have noticed it between 5 to 30 seconds or so, maybe more. Yeah,
Usually less.
Usually less. Okay, I'm just giving you the higher numbers. But so just compare it with what you would do normally if you're doing anything manual, right? So this is a very nice option of reversing traffic. Once you are sure that the target shards are what you want to use, you can mark complete. Complete can be also given the option to bring down the shards, etc. Show progress of.
And I have a question about the sharding here. So, is there some functionality there Vitess could analyze the traffic and suggest how things should be?
Yeah, we are talking about it within the planet scale context. Yeah, we have been talking about it. We've been fixing other things earlier, but yeah. Also, the thing is selecting Windexes based on query logs. So there are all these automatic things that we're talking about, but we haven't yet implemented. I think some of it is hard. I mean, there can be suggestions you give. So
Yeah, well, I think it's interesting because obviously websites, like the massive environments, right, you have, right, they typically have a very qualified teams, and they have need to have it very, very efficient. So
Yeah.
probably you have, they have a manual choices, right? But I think in a lot of environments, right, in the developers are kind of like an absolutely clueless, right, and
Right.
just running out of things.
but the problem there also is that if they're clueless, they might have designed the queries such that you have, like you're doing table scans or something. Then you need to fix those also first. So
Well, yes, yeah, or you can give him an option to scale by a credit card that have some maybe mediocre sharding, right? But you solve the problem.
yeah,
But in aftermath way.
yeah,
A manual thing that you can do is that you just have the V scheme as a JSON file. You don't need to move anything,
Yeah.
and you can still see what the clients would be. So you can take a query log and search for anti-patterns in that.
no, but he's
Yeah.
talking of coming from a clueless user who just wants to scale.
Clueless users are.
Yeah, I mean, in that sense, right? It's not necessarily clueless, but somebody who just wants to scale without like.
Yeah, and look, I mean, a lot of developers don't want to do
Yeah.
a database.
No, it is true. I think it's a valid point.
Just,
That's why we're here.
what?
They come to me. That's why
So Planet Scale is sort of doing some of this stuff, but yeah.
Yes,
Not
I
within
mean,
Vitess yet.
of course, but you can only be spread your love to so many people.
That's fair.
Yeah.
Yeah, so kind of related to the automating stuff over the future, is there any consideration or plans towards decoupling the key ranges from the infrastructure components? Because that would facilitate then something like triggering automatic resharding to distribute this particular key range to balance the shards better. Well, the infrastructure components.
Yeah. Yeah, right now we are not really tied into that at the moment. In the Vitess project itself, we are not doing it.
It's not being considered.
It
That
is
is-
possible though, but it is resharding because you're removing data. Even if you change the key ranges for those two shards, you can do that. You can make one like -60 and the other 60 dash.
Right, yeah.
But you are having to move the data, of course. It's a reshard operation.
Yeah.
Right? I think he was talking at a higher level, I think. The Kubernetes itself, you sort of spin off more pods. Is that what he's saying?
No, so what I'm saying is, like, if I have, I don't know, 3 sets of primary replicas, right? Those are my infrastructure components. On the current way in which it operates, is the key ranges will map specifically one key range to one set of primary replica, another key range to another set of primary replica, and so on. So if one of these happens to be hot, and I don't want to split it in two and then have 4 separate infrastructure components because the other one is idle, I would like to just move a subset of the data here. But that implies that the key range does no longer map to one single infrastructure component. So that's
So you can sort of what we call split merge. It's not as similar to it, but you can actually merge different ranges. Let's say you had 3 different shards with different key ranges. So you can merge half of the, first and the second, and the other half of the second and the third.
but I still have to make sure that they are contiguous, right?
That is decided by Vitess. Will tell you if it's. I mean, Vitess will not let you do it without it.
I think what you're like referring to is kind of like regions and chunks that Mongo has, and regions in Tidegate.
Yeah.
I've started to write an ROC about that, but it's probably a lot of changes. But basically everywhere it's assumed that shards are static.
Can I ask you 3 questions? It's just related to that diagram. First question is, how do you monitoring the system for performance? The second question is, how do you take backups over here in this environment? And thirdly, if one of those nodes went down, how would you recover? Or what do you do in this situation?
Yeah, so backups are taken. So the VT tablet component that I talked about also handles backups. So you can spin off backups using the control panel, and you can also have automated backups. All that is there. So yeah, here I'm specifically going into one aspect, but I'm not talking the rest of Vitess.
Sure.
So otherwise, yeah. So all that is there. Monitoring and everything is there. Yeah. So what is the third question that you had?
If one of those nodes went down, what would you do?
Yeah. So you have MySQL replication at each shard. So you have a primary and one replica by default.
Right.
Typically, you have two replicas. And there's VT which is an orchestrator, which checks that a primary is down, and it automatically will promote one of the replicas. So it checks that the replica lag is not low, and it sort of promotes. That's a whole different talk. Yeah. So the way the data is copied is, so there are target streams that run from the new shards to the old shards. The old shards, of course, have the actual data. So the streams only, so the source sends events. All the rows are sent as events, and they are reconstituted on the targets. Only those events are sent which are appropriate for the shard. And for that, we have something called in-key range, which is an extension to SQL that we handle internally, where we send the shard number and the Windex that is used. So we start with a copy phase, where we take snapshots on the source, and with the streaming select, send packets to the target. On the target, we create multiple insert statements, batch inserts, and we do it one table at a time. The reason we do it in batches is sometimes tables are very large. Most tables take like seconds and minutes, but there could be large tables in every database. There'll be one or two really large ones, which may take hours. So the redo logs can get very large, the history is length. So, and also, we want to track the binary logs once we start copying. Because all the new DMLs that are coming into the binary logs. So between the batches, we stream binary logs and update the rows that have already been copied. And we do it one table at a time. And once we are done, we move to a bin log streaming phase continuously until you cut out. So there are ways to monitor what the replication lag is, that is the seconds behind the source. So you would typically wait until it's just a few seconds and then do the cutover, because when you're doing the cutover, it will actually stop writes until it catches up. There's a _VT sidecar database on every target, which maintains state for the V-replication workflows and also for other things within Vitess.
So one table at a time means storage overhead is the largest table.
Currently, yes. I mean, I'm saying that because we are going to fix it. But currently, yes, that's what it is.
And the downtime is also.
The downtime depends on the traffic on your source, essentially, because when you cut over, typically you will have 1 to maximum 5 seconds V-replication lag. Typically, it's 1 second. So when you cut over, you only have to catch up for 1 second. But I mean, if you've done a million query transaction with million queries, it will be that. But typically, that's why it's very quick. So there are only a few events that you need to catch up on.
During the entire process, there is no downtime.
But yeah, during the entire process, there is no downtime.
I see.
Because the source is, okay, sorry, I'm not clear. The source is always serving to your production queries.
I see. But then storage overhead must be like 2x, right?
Yeah.
Sure.
Oh, that's already what you're talking about. Yeah, right.
It's like Nikolai presented earlier, like there's an overhead to copying things to another place.
So V-replication workflows are not just used for reshard, they're used across, even for the CDC purposes. We send out events, which are like the Besium has an adapter for Vitess. We also do move tables, materializer, lots of things, other things done. There's online DDL. There was, I don't know who was there for Shlomi's talk last year. 3 things, what?
3 minutes.
3 minutes, okay. So some properties, it's fast, but eventually consistent. During the copy phase, it's not. It's very resilient to failovers. We automatically check errors, sleep, and retry. There are various throttlings because you are streaming from the source, so you're affecting production actually. If production is affected, so you can use a Freno style replica lags or any show global variables. We also check the history length during the copy phase. Yeah, some indicative numbers, just 2 tables from recent, just to get an idea of how fast these things are. So yeah, by default now we drop secondary indexes before we copy. That we found was a very good optimization. Performance factors, other than the non-standard ones, data types, primary key data types also make a big difference. The row width, because we are actually parsing the bin logs and reconstituting the SQL queries, etc. So there's some cost associated. So it's very hard to give a benchmark for replication. There are some knobs, packet size, copy phase duration. You can do parallel copies while doing copy, and this throttling, which can affect replication. Some stories from the last 2-3 years for various people who have done. There are lots of blogs. I just picked 5. There's one interesting blog. I think Liz worked on it also, where we try to find out what it takes for planet scale to 1 million queries. I think we did with 40 shards. Yeah, something.
Yeah, something like 40 shards.
I think they're all very useful. Many of them also have the gotchas that are there with data access patterns, which are not directly related to sharding, but with distributed data. Yeah, so at this point, any questions about this? Because next, Andres Dali Taylor is going to take over. There are lots of images on his next one.
I'm shy, so if I'm not talking loud enough, just do this. Hi, I'm Andres. I'm going to talk about just a little component in Vitess, the VT-Gate planner. It's the thing that receives a SQL query, and it has the V schema and uses those two to figure out where to send the data, and then reconstitutes the results from the different MySQL instances back into one. So the VT-Gate proxy has all the capabilities that a normal SQL engine would have. It can do joins, it can do filtering, it can do aggregation, it can do sorting, all that stuff. So one approach that we could have taken is to just stream all the data from the base tables to the VT-Gate, and in the VT-Gates do all the slicing and dicing that you need to do with the data. That is not very efficient. First, you have to transfer a lot of data, and then MySQL is, in a lot of the operations that MySQL does, it's much faster than the VT-Gate proxy is. So we want to push down as much work as possible to MySQL.
Images, I know.
Where's my image?
Ah, there.
There it is. All right. So Vitess was developed at YouTube back in 2010, I think. And when it started out, it didn't have a query planner per se. It had more of a query dispatcher, where the application had to tell Vitess which shard to send the query to. Sugu, the founder of PlanetScale and Vitess, one of the founders of PlanetScale and Vitess, started working on the D3 planner, which was the first planner that could take a query and split it up and reconstitute the results back again. That was finished in 2017, I think, and it was the first planner that could do this. It had a lot of limitations, especially around the post-processing. So everything that happens after you've done your from and where, like the select expressions, aggregation, limits, sorting, all that stuff, that was difficult to spread across multiple instances. It was easy to spread the raw data ingestion, but then there were limitations on the rest. Okay. spent so much my tokens to get these beautiful images. I started working on the Vitess project 2018, and my background was I wrote a planner for Neo4j, a graph database. So I started looking at the planner. I said, this is something I could work on. So I started working on Gen 4. Gen 4, I started from the bottom up. The old planner, V3, used the same join order that the user gave in the from clause, which is good if you have developers that are good. If they don't care about how to organize the SQL queries, that could be very bad. So the first thing that I started working on was the join selection. In which order do we join the tables to make it as efficient as possible? And then it grew from the bottom up. Last summer, with the release of the version 18, we finished Gen 4, and it's now able to take on all the load. The V3 planner is removed from the code base. We switched there from V3 to Gen 4. It was confusing. At the time, we had Vitess V7 with a V3 planner. That was confusing to talk about two different V things at the same time. So now we talk about generational planners, and Vitess still has its own versioning scheme. So we received the query in text form, and no one wants to use regex to work with strings in a query planner. The first thing that we do is we parse it. We have one of the most comprehensive SQL planners in the Go code base. What we do is we parse it, we create an abstract syntax tree, which is basically an object representation of the query that the user gave us. It still doesn't know a lot about the query. It doesn't know which columns belong to which tables, what types we're dealing with. All of that information is not in the AST. So we do semantic analysis. We try to understand what the AST is trying to say, and we fill in a lot of extra information, such as typing, binding, we do scoping. And the result is the AST with a backpack that includes all that extra information. I don't know why. Once that is done, we can try to look at the query and see, do we need to do proper planning on it? With the semantic analysis, we know which tables are involved in the query, and we know where they live, and if they all come from the same key space, and that key space happens to be unsharded, we're done. We can just send the query down as is to MySQL, high five, job done. However, if it's not possible, we need to move into an operator tree. And in VTGate, we use an operator tree that's similar to the relational operators. I don't know if you took database courses at uni, but relational operators form a tree structure that represents the query. And it's filter, join, group by, and a bunch of different operations that need to be done to answer the question. We have one extra that is not normal, which is the route operator. The route operator is a thing that takes a query and sends it to the VT tablet or VT tablets if it's a query that goes to multiple shards in the same key space. Sends the data and then receives the results and concatenates the results back together so that it makes sense for the user. While we're planning things, we're pushing objects under the route. So everything under the route will be turned back into SQL. So we start from SQL, go to AST, go to an operator tree, and then everything that we're able to push under the route, we can turn back into SQL, because that's what we're sending to MySQL at the end of the day. While pushing things under the route, it gets a chance to look at what we're passing through. There you can see filters. So if it sees that we have a where clause saying sharding key equals blah, then we know we need to send it to the blah shard. If like Rohit mentioned before, we also have these secondary indexes. They help us map from a column value to the sharding key, so that we can figure out, by issuing an extra query, we can figure out which shard to send this query to, and not have to scatter to everything. It's like an old phone book. It's like an index, right? You have the primary key and the column value and the primary key in the same index, basically. We need to do cost estimation. So the planner will try a bunch of different ways of doing things. And the cheapest one is the one that is going to win. Cost estimation in the Vitess planner is mostly about these route operators. So we count how many there are and what type they are. Just like you have a table scan, you can have a scatter. Those are bad. You want to avoid them. So if we can rearrange the join order in a way so that we don't have scatters, we win. All the images was by Dali except one. Guess which one it was. So here we have 3 tables being joined, A, B, and C. The sharding key between A and B is used in the join predicate. That's usually how you choose the sharding keys. You make sure that joins are joining on the columns. That way we can push down. We know that the 2 rows that match are going to live on the same shard. So we can push down the join to that shard. And we don't need to do we don't need to send out as much data, and we don't need to do the actual joining. Most of the work that we do in the planner is about tree rewriting. So we go from one tree that represents the query, and then we change it a little bit, and it should still mean the same thing. Semantically, it's the same thing. If you join A with B and B with A, it doesn't make a difference, but one can be much faster than the other. We have 2 different types of rewriters. We have one-off rewriters that happen at specific intervals during the planning process, and we have rewriters that run all the time, which try to push down things. To give you an example, I want to use this query. We're going to go through how it would be planned. It's not a very clever query. I just needed something to show a few different operations. So we have a count star from a user and a user extra. And the important thing here is that they're not joined on the sharding keys. So we're not able to push down joins to the shards. We have to do the joins at the Vitess level. This is what my day-to-day work mostly looks like. I look at these trees all day long. For this query, the initial tree that we would start with would look something like this. The horizon here contains all the post-processing that we do. After the from and where is done, things live in the horizon. And we basically just copy over the AST fields into the horizon, or so that we don't need to go back and forth between operators and SQL and AST. If we're able to push the horizon under a route, we can just copy it over, we're done. If we can't, we need to expand the horizon into smaller components and see if those can be pushed down. The query graph is the unit that we will do the join selection on. So there we try all different combinations of joining things together. These are inner joins, basically. So if you have 2 inner joins and outer join with 2 other inner joins, you would have 2 different query graphs. The first thing that happens is that we need to turn the query graphs into real operators. The query graphs are just placeholders until we've done the join selection. So this is an example of what it could look like. So we have a join, we have two routes going to each of the two tables. We were not able to push the join under the route, so we have two routes. Horizons can't be pushed under joins, so we need to expand the horizon. I'm stripping out the rest of the information here to allow you to focus on the interesting bit. So we went from a horizon to an aggregator. That still means that we have to do a lot of fetching data from the underlying databases. And no one likes that. So in a Microsoft paper unrelated to distributed databases, we saw this cool algorithm that allows us to split aggregation under a join. So instead of doing a count star on the result, what we do is we do a count star on the incoming flows. And then projection here is how we evaluate things, how we can just run MySQL expression. So basically we're getting two columns with the count star from both sides, and then we're multiplying them together. Because we have many shards, it could be many of these multiplication results. So at the very top, we have a sum that sums everything together. And then we make it look like it's the count star that the user asked.
So actually, we are using the route operator as a, let's say, a pointer to the shard where the data.
Yes.
So you're traversing every shard until you find one in order to push under the route.
Come again?
Are you essentially using the route operator as pointer to the shard? So essentially, what I'm doing is searching every shard until you can push down the join let's say, operation under the route, right? Is that correct?
We don't need to look at shards to do the push. No. This can be done with just the V schema, like in a JSON file. You don't need a cluster. There are no interactions with the shards at this level.
Okay, that's my point, because these look expensive, but I didn't actually understand the game.
Senor?
Can you push down like an average or something by doing like a count and a? Yeah.
Yes. Yeah. We do a count and a sum and a count and then divide it. Yeah. It's a good paper. You should all read it. Here we still have the aggregation on top of the route, so we still need to do the aggregation at the Vitess side. But now one of these recurring tree transformations that we do all the time. In between the one-offs, we run a bunch of different rewriters that do the push-down logic until the tree stops changing. So maybe we can only push it down one step in the first run, but we run it again and again and again until nothing can be pushed down. And then it's time for the next one-off rewriter to do its thing. So here we were able to push the aggregation under the routes. And everything under the route will now turn into SQL instead. So this is what the two queries would look like that we send. So at the final stage, what we do is we stop talking about columns with column names or AST objects, and instead we talk about offsets. It's much faster to run with offsets instead of having to do lookups.
Can you show the original query? So, the point of the answer, so if you go back to the...
I should have them side by side.
So the bottom query there, where do you get the UEF?
Right. Apply join, another word for apply join is a nested loop join.
Okay, okay.
So
there will be several objects there to do this.
yes, this is not an example of a good query plan. You should not, if you have this, you're doing something wrong, and you probably need to update your sharding strategy. This is just an example. Yeah, so what we do is we fish out the UE foo and we send it down as an argument to the right-hand side of the joint. Oops.
This, you said, you said like they will do about that, right? But this join is made by, it's not by the shard. All data goes out to the aggregator and then you move data to there.
Come again?
Like you're fetching data from two shards in this case, two queries.
Yes.
But where the join is happening? In the shards or in another entity?
So, well, if the apply join is above the routes, it means that it's happening at the VT-gate side.
Oh.
So what are the resource limitations on that? Like, let's say you want to do like a full cross shard join. Like, is there like, what's the memory compute? Is that happening in a distributed set?
If that's happening, it's probably, I mean, you have to differentiate between OLTP and the case that is usually coming in and analytics. Analytics can be allowed to run for much longer. You need to be very careful about the many small queries that you do. Make sure that they, as much as possible, happen in a single shot.
Okay, the performance there, is that mainly that's on the VT gate, is that mainly done in memory or can it spill off the disk if the result sets are large?
It cannot spill to disk.
Okay, so
But the nice thing about the nested loop is that we can stream data as it comes in. We don't need to accumulate a lot of data. We get so here it looks like we're talking. It looks like we're talking with a single shard, but it could actually be many shards that we're talking to on the left-hand side. So we're going to get many results, and what we'll do is we'll manage one of those at a time.
okay, yeah.
We also have a hash join operator. The problem is exactly what you were talking about. So we only use that when this is not possible. There are some situations where you can't use the nested loop join. Then we fall back on the hash join. But OOMs are scary. All right. So far I talked about how to give the user the illusion that they're talking with a single database. But we do a little bit more than that. You have the illusion that you are talking to a single database and that you have a dedicated connection to it. You don't. The tablets do connection pooling, which is a really good feature that we provide. But that also means that there is no session state. You don't have anywhere to store your user-defined variables, your temporary tables, and all that stuff that you are used to having in your dedicated connection. So before we even start this kind of planning, we extract all of that from queries and replace it with the session that we hold in the VT gate for the user. We also do accumulation of statistics, like the OK packets, the TCP packets that come from MySQL contain a lot of metadata about how things went. Those are also kept up to date so that they look like what you would expect that MySQL to answer. I don't know how I am on time. Oh, so a planner has two things that it does that it needs to do well. One is try a bunch of different alternatives to answer the query that the user is asking. That could be called the search space. How big is the search space? There are tons of algorithms that will provide you with alternatives on how to take the same operator tree and change it into a different shape that still produces the same result. To tell which plan is a good plan from a bad plan, you need the second component of a good planner, which is the cost estimator. So something will tell you that this plan is cheaper than that plan. It's only an estimation, so sometimes the cost estimation will be off. And that is the problem that we have in the VT-gate planner at the moment. We don't have a very strong cost estimator. So my focus has been mostly on being able to mimic all the MySQL functionality, and avoid the worst plans. We haven't spent a lot of time finding the best plans yet. And that's what I hope to get started this year. The next version of the planner would have a cardinality estimator. It's something that can take a subtree of that operator tree that we're working with and say how many rows will it return. It's still an estimation, but it's backed by science and maths, so it's better than... At the moment, all we have to go on is what type of routes we have. But two options with the same route configurations could still be very different in cost because one returns many more rows before it's done internally in the tree. That's all I have.
Could event digests from the tablets help the planner? No. So basically, in the performance schema, could the counters of query digest cost be used in the BTGate layer to determine cost?
I'm looking at a lot of things. That is definitely one option. But even that, without knowing the cardinalities, it's not really enough.
Right.
Because you know the cost, but you don't know how many times that thing will be run.
Yes. Right.
Yeah. I'm trying to steal as much as possible from MySQL. The histograms is something that I'm looking at to use.
So do you query the MySQL for the statistics all the time, or do you store cache statistics in the mitigation file?
At the moment, we don't. At the moment, we don't have a cardinality model. So no, we don't query the statistics. We'll probably need to.
Usually when we talk about experience planners, that's planners either top down or bottom up. I'm not sure how your tree transformation fall into that. Is that?
It's a good question. I think it's a top down because we start with the whole tree. But I'm not sure. Yeah, that's a good sense.
Really big question. How do you know the planner works? Or
because our users are happy?
There's a whole bunch of unit tests. I mean, there's a massive amount of unit testing done.
Yeah.
Or maybe better question, like when you introduced Gen 4, how do you compare it to Gen 3, or was there anything?
V3.
V3.
So yeah, that was a good. So we no longer compare with V3 because we don't have V3 in the code base anymore. But what we did is we looked at the plans. Every time they produced different plans for our test suite of thousands of queries, we looked at both sides and saw which was the better one.
Yeah, I guess you have to, yeah.
Yeah, so we also have this different project called RV Fastate. That's a benchmarking tool that's running constantly on all the PRs. So you can request, and it does it on, I think, every PR, or at least on the release versions. But you can also request it on the PR, and it compares TPCC benchmarks against the previous PR. So we're tracking it very closely. Yeah.
Awesome.
You just slap a label on your PR and you get benchmarks.
Yeah, it needs testing or something, yeah.
Yeah, that's the only way.
Benchmarking.
Yeah.
What I understood, I can have queries doing jobs where Vitess is going to split or rewrite the queries, right? And goes to the shard. How do I know in the shard, like, to track who is the source? You know, because if the query is different, how do I know?
That's a good question. That's not the first time I've heard. I don't think there is. Maybe you know.
No, I mean, they all get executed. I mean, because we're already using connection pooling, we're using these fixed users to actually execute. So the MySQL server itself doesn't necessarily know.
Yeah.
But from a Vitess standpoint, we can still track it down.
What we can do, what we've done in the past is if the application slaps a comment on the query, we copy that comment to all the subqueries, and that can be used to track what the original request was. About testing, we also do a lot of fuzzing between Vitess and MySQL. So we want to be a drop-in replacement for MySQL. So we just make up random queries and run them both against the vanilla MySQL and against the Vitess cluster, sharded Vitess cluster. And if they don't answer the same thing, the test is broken.
Right. Have you tried running a MySQL test suite against VTGate?
Which, no, I have not.
Good idea, though.
We haven't spoken about performance. And when you talk about it, it looks like it's going to take a lot of time, but we of course are fast. So. Yeah, so I think like 1 to 4K per VT-gate is per queries per second is what I've heard in production. I mean, I don't know a lot about it. So typically you run thousands of VT-gates. I don't know how much the Slack run for the large hubs.
More than 1,000.
Yeah. So they are behind the load balancer, and if you're using Kates, we already have the operator already does the load balancing.
They're easy to spin up. They're stateless, so most of the things. All right. Thank you.
Thanks.